Lightning talks. That's what's next on the menu. The rules of the games are simple. We'll have a series of presentations, 5 minutes each. And yesterday has shown that the countdown is not enough. So we're going to have a bell, okay? So when you hear the bell, run, okay? We don't take any questions. There's a very, very nice selection. There were a high number of applications for these lightning talks. I believe there were over 50. So the selection wasn't easy, but here we go. So I'll call now our first presenter, who is well, all these lightning talks are examples of the EOS community. So we'll start with an example of national catalog of repositories. This is a Czech pilot for EOSC. I'll have the pleasure to welcome here Alexander Kucinka from the National Library of Technology, Czech Republic.
Thank you for your nice introduction. So I'm from the National Library of Technology, Prague, and my lightning talk is about one tool we are currently developing there. It's called National Catalog of Repositories, and it constitutes one of the core components of the Czech national data infrastructure. I'm not the right guy to tell you about Czech national data infrastructure, so I won't go into details. But yeah, new disciplinary repositories for storing research data are emerging in different domains, scientific domains, within this infrastructure. That's great. But the NKR, the National Catalog of Repositories, should provide a unified, a structured place where information about these repositories, about the whole complex of information, semantic, technical, whatever, from the very beginning stage of development of the repositories, is described in a unified, machine actionable way from the very beginning. So, what is the architecture? It consists of two tightly integrated modules, let's say. One is a knowledge base, is maintained in Cordra software, which is, by the way, used for the data type registry, as you might know. Every repository is represented as a digital object with a persistent handler identifier, which enables reliable referencing across the ecosystem, which is a very important thing to have a persistent identifier. And the second module is for controlled vocabularies. It is basically Cosmos, which is an open source software developed at the National Library of Finland. And when new vocabularies are developed, we are applying FAIR principles from the very start. And all you know the FAIR principles, accessible to both humans and machines, vocabulary level metadata included, and so on. So this is very important. But that's the thing I want to stress today. We decided, instead of developing a standalone metadata schema presentation module, because the NKR should include the metadata schemas used by the disciplinary repositories. So instead of developing standalone presentation module, we decided to directly integrate with the metadata schema and crosswalk registry. Is a tool developed within the FAIRcore for EOSC project, which ensures that this information discoverable and reusable access the whole EOSC ecosystem. Another thing, the metadata schema for the NKR is designed in such a way it enables to encapsulate also the FAIR enabling resources. and keep the link to their respective nano-publications. So we are keeping the linkage to the nano-publication ecosystem, which is another important thing. So we are currently in the testing phase, and we hope this phase won't be too much painful, and that we don't get stuck for too much long in this phase. And hopefully the experience acquired in the process, the good one and the bad one, could be of some benefit to the whole EOSC community. So thank you for your attention.
My God, that was perfect. How much did you rehearse to be so on time? I know they come up before I even called them. I think maybe I've put too much pressure on you with the bell. Now we'll move to Norway, to Simula, with Anne Fuyu from the Simula Research Laboratory, and you're going to present at Oscar's Fiesta, Fair Image Analysis Across Science.
Yeah, and I will first start because I'm no longer in Norway. I'm working with LifeWatch Eric in Seville. That's first. But let's go back to the Fiesta. So fair image ecosystem for shared tools and analysis. So, oops, I went too fast. Who we are and where we start. So we are 3 different communities: the bioimaging community, the astronomy community, and the environmental science community. And we are working on the same problem, which is image analysis, but in our own world. We have different types of images, and what is common to the 3 communities, and we have new pressures in our respective communities, because now we have more data. We need to use cloud, we need to use AI, and also people developing AI wants to use our data, and we have more domains willing to collaborate with us. But we are exploring this new solution independently. So what we wanted to know is, can we work more together if we are fair and if we are using fair enabling resources to be able to do this standardization effort together instead of in isolation? So we started with a FIP, with a Fair Implementation Profile Wizard, because we can document what are the current practices in our respective communities. So that was a starting point. And what we found out is this is very, very important tool, we believe, because in our domain, we can discuss and agree on what are the most common practices, if they exist, and what we should advocate in our own communities. And across domain, what was very important is also to find some commonalities so we can have an entry point for discussing. Because when you are so different, you don't know where to start. So the FIPS enable us to find out, for instance, we are using rock rate. So let's talk about rock rate so we can have an anchor point and discuss further. But what the FIP didn't manage to help us was to surface what we are exploring, because we only documented what we are doing or what we did, and very little what we want to do and what are the pain points and what we want to address in the future. So let's take an example with data format. We all are struggling with our own data format. We have standards, but the standards are not suitable for cloud data analysis. They are not also suitable for AI ready. And we are all exploring in our own silo on how to address this problem. And we are developing new standards, bottom-up from the community level, discussing on how we could address this problem. But we are not discussing with other communities. So for instance, in microscopy, they are using OMI-ZAR and discussing ZAR is a new data format for cloud data analysis, but it's not discussed in the FIP. The same for environmental sciences. We are discussing GeoZAR, EOPF-ZAR, so different types of ZAR, but again, this is not addressed in the FIP. And for astronomy, they also say, okay, we should also have some cloud format, but again, this is not in the FIP. So the standardization effort, they are still happening in silos. And we don't have a way to document this in any of the tools we used. So what we are advocating is if we want to break the silos, we really need to explore and document what we are exploring and the pain point, so we can early align with other communities and to avoid creating new silos with new standardization effort. So that's what we are advocating. Use FIPS to document not only what you did and what you do, but what you want to do. And that will reveal potential conversion earlier. And this is, we believe, very important. So for instance, in the FAIR to Adapt project, which is climate adaptation, they know nothing about FAIR. But if we apply this approach and a FAIRification framework, we will avoid to create new silos. And that's it for my presentation. Thank you.
Thank you. Next is Felicita Sommer from the Technology University of Munich, who is going to tell us about BIRD at NFDI. Sommer, over to you. The clicker is there.
On the green one, okay. Good morning. I am very honored to present to you how BIRD and Galaxy infrastructures can help to make local administrative data accessible and usable for various users and in a responsible way. In my research team, we want to understand the role of spatial governance for social, economic, and environmental targets. Problem is, this requires a lot of expertise from different domains that are currently not well connected, and there are technical, legal, and institutional barriers to access documents that contain, for instance, local planning decisions of public authorities. These should be accessible to science. No controversial statement in this room, I think. It determines what can be built where and how on parcel level with graphic and textual specifications, from housing to renewable energy to flood retention. Quite relevant, even for open science, if you want, for example, green and climate resilient open data centers, open science data centers. So in an ideal case, binding land use specifications are available as findable, accessible, reusable, and structured data sets in interoperable systems. Well, with active plans from the 1930s to today, you have to encompass all varieties of handwriting, typewriters, and software applications. Online availability of PDFs or scanned paper plans like this one depends on financial resources, on expertise and willingness of local municipal employees. From science fiction literature, we know if you are a Vogan and you want to destroy planet Earth for developing an intergalactic highway, you should publish the development plans on the planet Alpha Centauri, where humans are unlikely to object. From human spatial planning perspective, the problem is actually reversed. Binding land use plans are too much embedded in local communities when it comes to the beyond local challenges, like, for example, nature preservation, climate adaptation, or affordable housing. In order to cure spatial planning from its short-sightedness, we wanted to shift the focus from single documents with unstructured texts to structured data, thematic maps, and visual representation of relevant restrictions in one area. So who are we? First, there's BIRD at NFDI, a research data infrastructure for business, economic, and related data with a focus on making unstructured data more accessible and building a fair federated research data infrastructure. Then Galaxy, that supports reproducible, scalable open data analysis with an open source framework for assessing and sharing data, tools, workflows. And GreenDia, an interdisciplinary research consortium connecting various disciplines to create new sustainability data, indicators, and algorithms for the built environment. Now, this is the workflow we developed, and it's in progress, it's still improving. And in the first step, we uploaded the data set on BERT. Now you can use it as an input to the workflow and open it in Galaxy. And now there's a video, actually, that you can see in the booth. But here, I don't have enough time for showing a 4-minute video. And so when you have uploaded the metadata, then you can query the municipality that you're interested, for example, Alzenau. Then it's downloading the PDFs for which the dataset provided the metadata and convert PDFs to images, which is important for the OCR process. Keywords can then be extracted with an LLM and shown as a word cloud for Alzenau. Then you can save the results back in BERT, and the BERT dataset can then be exposed to the EOSC EU node via OpenAir. With BERT, Galaxy, and the EOSC Federation, we have tools and infrastructures to process unstructured data and share meaningful information tailored to different research topics and applications. This would hopefully help to overcome silos, to facilitate collaboration, build interdisciplinary learning environments around the boundary object like spatial regulatory information. One of the challenges is that we can underestimate data gaps, underestimate complexity of regulation, and neglect informal social practice. By reducing technical barriers and providing ready-to-use workflows, it will be much easier to keep domain knowledge close and access that practical knowledge. And hopefully, as we start this together, we can also recognize open science as an important prerequisite for usable spatial governance information. So I just want to say, I experienced myself that this is a very inclusive community for newcomers, which enables our team now to reach out to other disciplines, to create new use cases. And so a big thank you to everyone who helped in this use case, and especially also to my colleague, Hope Evudor. And if you want to discuss more, then please visit us at the stand, at the booth. Thank you so much.
Thank you. Now we know what the bell sounds like. Next, Elixir on Cloud, standardizing federated analysis in EOSC. So you're Ivan Janmat, and you come from Surf in the Netherlands. Ivan, 5 minutes.
Yeah, thank you. I just put off my Surf hat now because I'm doing this talk for Elixir as part of the Elixir Compute Platform, and it was a nice introduction to see the workflow that was in the presentation before. This is going to be about workflows. We've seen some workflows yesterday with Rihanna and also Galaxy. And basically, it's a process where you have multiple tasks and you connect the output of one task to the input of another task, and you can run the task parallel or serial. And it's very handy because you, as a researcher, you can define your workflow in a workflow language. And of course, there's a common workflow language, but that's not the only language. And there's also SnakeMake and Nextflow. So it becomes quite complex maybe for a not that well-skilled researcher to work with it. So the idea and the vision of Elixir was to create a workflow execution service who can kind of determine which workflow we are working with and then kind of route that in a proper way. And then, of course, there are also multiple tasks that are in there, and not all tasks are handled equally or can run on different systems. So you would also like to have a task execution service that kind of puts the tasks on the appropriate server. Well, that's all theory, of course, and we would like to have a use case. And, well, in health you have use cases, but I'm also involved in Entrust, EOSC Entrust, and also there are other use cases as well. But I've taken the health one here. And there will be a European health data space, but that European health data space will be setting up health data access bodies in every country. And if you want to securely process something of that information, that will also be different in different countries. And some countries will require SPE, secure processing environments. Other will require theory, trusted research environment. So it would be nice maybe to use this task system to distribute the workloads evenly across this. And basically, that's what we are thinking of. Next year at SURF, we will be focusing on creating an Elixir node at the EOS node at SURF. And I think, yeah, using this technology can also enhance other EOS nodes. Yeah, there are a lot of workloads that are distributed across Europe, I think, eventually. And I think EOS can be a sort of common ground where we have all this stuff that we need to do this, like the federated identity, the authorization, especially the authorization with the triple AI, because we also need the auditing across all the nodes to really make it happen in a secure environment. And of course, there will be something with budget and billing going around as well. And research data management is also important. And all these things are within EOSC. So to make the vision of Elixir possible, I think EOSC can contribute a lot to it. And we like to work together on this. There are other people from Elixir here in the room as well. So if you have an idea to work together with us next year on making this happen on EOS nodes, please contact us. That's it for me.
Thank you. So we are now going to transition from health to ocean, talking about digital twin ocean in the EOS Federation, from data to impact. And for this, it's my pleasure to call Pasquale Pagano from Blue Cloud 2026 from CNR in Italy.
Okay, thank you. So this lightning talk is about the digital twin of the ocean, a candidate thematic marine node in the EOSC Federation. So let me start from the challenges that we observed in the marine research. First of all, critical data is spread across disconnected infrastructures. And so integration is possible, but quite complex and time-consuming for any researcher. Also, the analytical tools and the workflows are available in specific communities. And these compromise and hinder collaboration and cross-disciplinary research. There is a lack of a unified way to access computing and storage resources that are needed to manage the large amount of data that are accessible. And there is finally, and the most important maybe, a lack of trust and transparencies. So it's difficult to track data provenance, it's challenging to verify results, and it's very complex to reproduce scientific workflows. So all those challenges require, an integrated solution. And what we try to do with the digital twin of the ocean node is to provide an integrated environment built on the EOSC principles. So first of all, deliver through the node fair federated data services that are harmonized data collection with advanced subsettings, semantic enrichment, and provenance tracking in a way that researchers can get exactly the data that they need with full trust, and then deliver to the researchers an integrated virtual research environment where they can use interactive computing, like Jupyter Notebooks or RStudio, reproducible workflows with the Galaxy and our cloud computing platform, and pipelines for containerization and application management. And we do this, trying to integrate EOSC with the European digital twin of the ocean in such a way to create one digital ecosystem for marine research. So in this way, our aim is to deliver a trusted interoperable tools and seamless access to data. So in practice, what we do, we enable real-world cross-disciplinary use cases where researchers can access in situ and satellite data from the key European services like EMODNet and Copernicus Marine, but combine them with the specialized observation from marine research infrastructures like EuroArgo, carbon data from ICOS, and deep sea from EMSO. Altogether, this integrated data set can then be processed using interoperable workflows in the Blue Cloud Virtual Laboratory, with the result directly contributing to the European digital twin of the ocean and shared openly through EOSC. These essential tools that we are putting together also contribute to the ambitious goal of the EU mission, Restore Our Ocean and Waters. And let me say that the approach that we are taking is not just for marine research. We are integrating technology, following the EOSC principles, and making available this technology also to other communities. And the same technology, for example, so far is used also by the Italian node, another candidate node of the EOSC Federation. Overall, we would like to say that the EOSC Federation principles accelerate scientific discovery and generate tangible societal impact. So let me conclude saying thank you for your attention and inviting you to two sessions that we organized just after the end of the EOSC Symposium, tomorrow after lunch. In the room that you see, there will be two sessions if you want to learn more about the digital twin of the ocean. The first one is about the marine thematic services, and the other one is about the core and generic services of the EOSC digital twin of the ocean node. And in this session, we also host the presentation of two national infrastructure, one from Poland and the Data Terra one. Thank you.
On the dot. Well done. All right. So now we're going to move to climate, to the Climate Adapt for EOSC project. And for this, I'll invite Thanasis Vetsos from NCSR Demokritos in Greece. Welcome.
Thank you very much. I'd just like to present if I manage to make this work, an overview of the Climate Adapt for EOSC project, which is one of the projects started last year with the scope of blending the climate community with the EOSC approach and the EOSC community. So I think we have this task of making different communities talk to each other and making all the different information from shifting between the digital and the physical world in a seamless way. So this is pretty much the project. And what we would like to do is that we know that there are many different data spaces coming from the climate change sciences, from the social sciences, and we want to put them all together in a way that they will mean something for the community. We want to have use cases and we want to demonstrate that using the EOSC approach, the EOSC concept, and a fair compliant data set and open science practices, we can generate added value that has an impact for the community. And to do that, we implement several different approaches that I'm going to present here. We have a generic architecture where we want to combine different data sources, different agents, middleware platform, and a verification pipeline that will allow us this smooth integration between data, spaces, people, and communities. And this one is something that we want to make it standard and interoperable. And of course, all this output data will be presented in accordance to fair, compliant services. Another element that we want to do is that we know we generate a lot of data sets. We generate different types of data sets coming from Copernicus, coming from local sources. And we want to make them in accordance to the FAIR principles using knowledge from existing FAIR EOSC project, like the FAIR impact, but also to collaborate with our sister project, FAIR to Adapt, in order to generate common approaches, maybe the RO-Create or the I-Adopt can be something common that will stay a legacy of the two projects and the community overall. And we would here, I think it's very important that we would like to challenge that the FAIR does not mean that data should be open, but also mappings, metadata also should follow same principles, and this is something we would like to build on. Very important, for us at least, is that since we know that we have a very diverse community and a diverse set of actors and stakeholders that are integrated into the project, that we want to focus and rely a lot on the legal and organizational interoperability and the challenges that follow the semantic and the technical ones. And to this solution, the CIDE framework is a very critical part of the work and the approach that we follow. And based on that, we want to implement AI-based solution to build interoperability and data integration where the people have the human-in-the-loop model. So we want to implement this in 3 different case studies. The first one is about the urban resilience to heat wave, and here we have a local community, which is a very highly valuable population, and this is where we want to implement a digital twin with many services where the people and the citizens will have a saying and will be able to contribute in this perspective. And this will be replicated in 3 other cases around Europe. The second one is related to the marine environment and where we can generate synergies with other projects mentioned here, where several different elements related to marine protection and early warning system for extreme events in the ocean can be made available through this FAIR process and these EOSC pipelines that we want to develop. And the third one is about the String-Swell case study from space using Earth satellite data, which is a very important context on how to generate new services for people and new hazards which are not very well defined and have a potential big impact in the community. Closing my presentation, I would like to make an invitation to the community, you, to join us through a stakeholder forum that we have approached, and you can register in this address or through this QR code, but very happy also to discuss with you outside this project. And with that, I would like to thank you very much.
Thank you. So we'll keep going with lightning talks and demos, and now we're going to Krakow in Poland. And so we're going to hear about an example from National Resources to EOSC, right? With the EOSC Node Poland Gateway. Yeah, so
sorry.
I'm here, yeah. So,
can you hear me?
Where are you? No, you can go there.
No, I will stand here.
All right.
If that's fine.
So, pleasure to introduce you,
Thank you.
to Roxana Wilk.
And yeah.
Yeah, and so you are the head of data processing laboratory in Cifranet, AGH, in Krakow.
Thank you.
You go ahead. Do you prefer
yes.
walk? Yeah,
I
right, you have the
here.
mic.
And a
Go
quick
ahead.
disclaimer, there was a lot of amazing work done by the whole group of people. Most of them are here back in Poland as well. A lot of our colleagues from other nodes. So I have a very tight script. I will be reading fast. I might be hard to be understood. If that's the case, I apologize. And I do encourage you to come to our booth. Now, if we can start with the presentation. Thank you. This demo will introduce you the EOSC Node of Poland, a national initiative of so far 5 scientific institutions. In the next 5 minutes, you will see how our services at EOSC PL take you from searching to researching in no time, offering a single gateway to trusted interdisciplinary data. And here is our challenge. Research often starts scattered, dozens of sources, mixed standards, and compute far away from where the data lives. Massive data sets being shuffled manually between systems with a pit stop on the local drive. Precious time is slipping away tackling side problems before even the real science begins. EOSPL comes to your rescue as your research gateway. Sign in through EOSC AI services and explore aggregated data repositories, combine public datasets with non-public ones, possibly cross-organizational resources shared within your team, run computations directly on virtuous data, and publish your results without effort. Among the core components, we have the one data that you see, which is our data layer. It brings together distributed storage resources of partner organizations. Beyond that, it references public data sources without copying, reusing datasets from other EOSC nodes and open repositories. And with seamless AAI, VO, and group mapping, users can collaborate on shared datasets the moment they log in. It gives the researchers full control over data distribution and locality. You can pre-stage files, set up replication rules, or let the system decide for you what is best. The data will be delivered on the fly when needed. Thanks to the standard interfaces, our data layer integrates smoothly with diverse computing environments, and with its tight connection to the portal and catalog, it provides you a truly seamless experience. So let's see it in action, shall we? Let's access the interdisciplinary data on the Baltic Sea, including satellite imagery. Here is the research question. Can we predict the harmful algal bloom occurrences by analyzing environmental factors, such as temperature, waves, currents, sunlight, and chlorophyll levels? For this journey, we will need to discover distributed data sets and organize them in a shared data space, run a computational analysis, gather results, and publish the package for others. Along the way, we will reuse data and services from other nodes, including Galaxy, to run a workflow. First, we search for the interdisciplinary data. We find data sets from Copernicus, Marine Services, EMODNet, EEA, and ECUDO, some directly, some others with the use of the EOSC catalog. They include the tabular data, satellite imagery, and in-situ measurements. And then, together with the team, we import and organize data in a shared space where we will also store intermediate and final results of our research. Well-curated metadata helps us manage and understand the data more effectively, while creel laws keep collaboration smooth. Next, we decide to process our data sets. The data layer works with environments such as HPC clusters, Jupyter notebooks, or containerized apps. Today, we will choose the notebooks, the Galaxy platform, which supports reproducible computational workflows, and a quick login using federated AAI, and here we are inside. Thanks to the existing integration between OneData and Galaxy, we can seamlessly plug in our data sets without copying. With the deferred resolution feature, data will be delivered in the background from nearby storage systems and remote repositories just when needed. Then we specify the inputs and run the workflow. Execution takes place on the Pulsar server using EOSC resources. The workflow is finished. It identified correlations between environmental parameters and produced spatial risk analysis for individual buffing sites. Here you can see the resulting outputs visualized. They are saved back to the same distributed data space together with provenance metadata from the Galaxy execution. Finally, the last step, as you remember, we publish our results. The process is simple thanks to integrated PIT and DOE minting. We provide rich metadata to ensure proper context and reusability. Shortly after, the new public record is automatically aggregated in the EOSC catalog, making it discoverable through the same gateway as we started, so other researchers can find it, cite it, and build upon it. The system supports us in every aspect of the FAIR principles. Our published package bundles everything needed to reproduce and extend our results. It references our input data sets, rich metadata, the steps we took, parameters, and the outputs. The single package ensures the credibility, transparency, and reproducibility of research in the spirit of open science, obviously. And at this point, our struggle is done. And with EOSC as our research gateway, we gain a unified space for data, compatible with diverse tools, ready for analysis and built for sharing. Our results become discoverable, reusable, and a part of a wider security and scientific ecosystem. EOSC makes a real difference. It's operational, so if you want to try it out, the package is available in eosc.pl. You can download it and try it for yourself. Have fun.
All right. So there was quite a rhythm indeed. The good news is that Roxana has a booth. So if you couldn't absorb it all, there can be a catch-up session. All right, next is Hannes Bunche from Robert Koch Institute in Germany, and you're going to talk about creating trust with fair open data, the RKI in the pandemic. Over to you. Yeah, tell me.
May I add one thing at the start? So the RKI is the central governmental body for public health and disease control. That was the context information in Germany. I couldn't fit into the presentation, sorry.
And it wasn't in your 5 minutes, so
yeah,
that's good.
I know, sorry. Okay, yeah, thank you for having me. There should be a next slide already. Is it? Okay. Well. There it goes. Okay. At the beginning of the pandemic, the data on I'm confused. It's not progressing. Okay. Well, the data on COVID-19 was quite scattered. So we had different portals, third-party. Okay, it's not my presentation. It should be a video, no? I'm sorry, I expected a video to play. So that the data was quite scattered all over the place, and actually, now the video is playing. Yeah. It's fine. Now it's playing. And actually, a lot of people were not really happy with, about it, especially the news media companies that were relying on the data on a day-to-day basis. And on the other hand, we had people protesting in front of the institute, demanding for more governmental transparency, actually saying that it's the state that is sick, not we. And as a governmental body, I can promise you this is not a really nice situation, and we said, okay, we have to do something about it, and we can do something about it. So in order to tackle the whole question of transparency, of course, we needed long-term archiving of our data and persistent identifiers, and so some of you probably guessed, we said we have to use Zenodo, of course, to publish our data and create a single point of truth. So we created the Robert Koch Institute collection there, and as of today, we have around 10,000 versions of our dataset published. It's about 46 datasets published there on all different topics. And if you jump into one of our datasets there, you will see we have rich metadata, and what I really want to highlight at this point, and was really important, especially in the communication with all the stakeholders out there, is an extensive data documentation in order to answer the questions that are about the data genesis. And besides the Zenodo, and you can see that on the left, we also decided to use GitHub as a second platform for our data. So if you follow the link, you can see the data set on vaccination data we just had is also mirrored to GitHub. So you find the data there, and you also find the documentation there, all the metadata, the persistent identifiers. And this is true for all the data we have. So on GitHub, there is the Robert Koch Institute organization. You find all the data that is on Zenodo as well there. So why do we do this? And why do we use GitHub? And this is actually something I really want to highlight. GitHub is the social network that is actually used for software development, a really cooperative, collaborative process. And with GitHub issues, GitHub features a social space where you can ask questions about the data set in this case and give your input on it. And we used it as a feedback channel with the stakeholders and users for our data. And as you can see now, we have a lot of comments, and they are all fortunately closed, so we could resolve all the issues. Really extensive questions about the data we published there. And for instance, here you see an issue on the documentation. Something wasn't really clear about the vaccinations, new shots coming in, how is it represented in the data. Others liked this question and said, yeah, this is important to us, and we engaged with them like in the forum style, yeah, talking to each other. And this is all public. It's really easy to access. It's really easy for you. You could just open an issue if something is not clear for the data. And this was a total game changer, because suddenly there was a feedback channel and the community could interact with us. And that made really a huge difference. And we also had people, of course, complaining, where's the data? Because sometimes something happens, an update fails, and so on. So did we succeed in our journey in order to create this trust? I'd say yes. And you can see here, before actually we used GitHub, the data journalists were organizing themselves on GitHub. So we said, well, if they do it and if that fits their needs, maybe we have to do it too. And we did that with the aim to, hey, it's our job to publish the data for you and to present them in a good way, and we succeeded with this, I guess. Thank you.
Perfect. Great. All right, we're now going to talk about lowering barriers to fair adoption through EOSC Fair Wizard. And for this, Jakob Jirka from Code Event Solutions Czech Republic will tell you all about it. Welcome.
Thank you. Hello, I'm Jakub from Fair Wizard. More than a DMP tool, it is a platform that enables fair, machine-actionable, and data-driven research. For researchers and also penguins, adoption of the FAIR principles can be challenging. Fair Wizard doesn't give them a checklist. We give them a compass. Real-time feedback, practical guidance, and smarter planning, all built into your research processes. Our demo will start outside of the Fair Wizard in a CRIS system. Because we don't like double filling of the information, we will take our administrative information, use an API integration to create a DMP for our researcher. Now we will go to the tool itself. Here in a Fair Wizard, our researcher is start doing the data management plan. They choose to answer no for a question if there will be any existing data, and they get clear response, guidelines that we are usually having pre-existing data, and there are some places they can learn about what and how they can do. So our researcher goes to the RDM Kit website and then learn about reusing the data. They find out that there could be some domain-specific repository they could use. So they go back, they change the answer, and using another integration, now with the FAIR sharing, they will find a data repository, pick it up, and you can easily go to all the details directly from the tool. Now, another guidance here. We have a metric. Metric can be associated with any answer, and by answering, the researcher sees how it affects the specific metric. Here in a short demo, we can see in the overview they didn't made well. So they can change, learn more, and change the research to be better in metrics. I will show you now some bigger report, how it can look like when the data management plan is filled up to some degree. There is a nice graph summary of the metrics. It doesn't have to be only FAIR metrics. You can define your own that supports your use cases. So now the first part is finished. Our researcher creates a first named version of the questionnaire, and they go and create first DMP document. It will be the Horizon Europe one. Now, a third option how to evaluate and educate is an integration with the external tools. Now, our researcher wants to get another check that everything is on track, and they will be using our MADMP evaluation service that is delivered in the OS Trails project. They basically submit the MADMP to the external service, and they will get a nice review of the test, what happened, and possibly later on what they can improve. Guiding individuals is not enough to make your research in the whole organization better. That we in the Fair Wizard present an analytics where we can showcase you how all the projects are going, if it's good, bad, and different views for different use cases. If you embed the FAIR into your processes, you can make your life easier and deliver better science and research. Thank you very much.
Thank you. Conclusions are perfectly aligning, it sounds. We have a duo next, a French duo. Jérôme Detoc and Marie-Josse are going to talk to us about From Plume to Bloom. right? So you'll tell us what this is. So it's the Data Terra Research Infrastructure and EOSC. Jérôme, you're a Marine Data Systems Engineer at Ifremer, and Marie, you're a Research Engineer at CNRS for the Data Terra Research Infrastructure. Over to you.
Let's go. It starts in the Pacific Ocean, a place where the Earth still braces through its cracks. And sometimes it speaks too loudly. What exactly happened to our planet that day?
When a volcano erupts, it throws ashes and forms a plume that can rise to the stratosphere. To follow it, we use the eyes of space. Imawari 8 and Sentinel-5P tracks volcanic ash aerosols and SO2. But we also use Argo float drifting through the ocean, recording temperature, oxygen, chlorophyll. And scientists even collect omics data. Each observation tells part of the story. The real understanding comes when we connect them all.
After the eruption, satellite data showed an intense green signal, a possible bloom of phytoplankton across the Pacific. But then came the debate. Some researchers claimed it was real, others argued it was only an optical illusion, a bias caused by volcanic aerosols disturbing the light. Should we trust the satellite or look deeper into in-situ data to find the truth?
To explore this question, researchers gathered during the EOSC Ferries and Neuroscience Gateway Hackathon. 3 days to make data from different domains speak the same language. One studied volcanic plume with the Volcano Space Observatory managed by IRIS, which shows the spread of SO2 in the atmosphere. But that's only half of our today's story. The ocean tells the other half, but it doesn't always speak clearly. When the air fills with ash, light bands and sensors get confused. Normally, more green means more chlorophyll A, a marker of phytoplankton, the base of marine life. But when the sky is full of particles, that color can lie. A third explored after that Argo biogeochemical floats in Sinoi, collecting data that satellite can only guess, just the ocean talking directly. So we need to bring everything together, the sky and the sea, the pixel and the particle, the scientists and the data.
First, follow the volcanic plume. Where did the ashes fall into the ocean? Then compare chlorophyll signal with ocean data view. If chlorophyll A signals rise where ashes fell, maybe life really did enter the volcano. That's where the pieces start to fit. After hours of searching, cleaning, and aligning data, the inputs were finally ready. Last day of the hackathon, 3 hours left. There is where things start to make sense.
Now, imagine connecting all these steps inside one ecosystem. That's what DataTerra and the EOSC are building. A federation not only of machines, but also of people and knowledge. A space where scattered data can finally meet.
Inside Galaxy Earth system, tools and workflow connect together, created a shared environment for Earth data. We aim at building a network where atmospheric, oceanic, and biological data can finally work together. With Terra Map, we can visualize everything, from satellite to sensor, from the sky to the sea, all in one place. That's interoperability in action.
In Galaxy, each tool links to the next, building a network where Earth data can finally work together. Add EOS services, Galaxy, Pulsar, Zenodo, Workflow Hub, and you get the full cycle of open science. Processing, sharing, reusing. Knowledge that moves and grows.
Pulsar for distributed computing.
Then we can use Zenodo for sharing.
And Workflow Hub for reuse. Together, they build a full open science loop.
With Galaxy, data, tools, and people work hand in hand. We move from open science to collaborative science. 20 years later,
another revolution.
A workflow to be reused. Thank you.
Thank you.
Thank you, and special congrats on the creativity of the presentation. We're now going to talk about an intelligent system for discoverability and collaboration with Nafis Tanvar Islam from the University of Amsterdam. You can go here, and whenever you want the video to be launched, you just say so. All right?
Oh. How do I start the video? Okay. Hello and good morning, everyone. I'm Nafis Tanvar Islam from the University of Amsterdam, together with my supervisor, Dr. Ziming Zhao, and then Federico and Martha from EGI Foundation, Delphine from EuroArgo, and finally Ulrich from ULISH. We're building an intelligent system to supercharge discoverability and collaboration in the environmental and earth sciences. So early career researchers in the environmental domain struggle to find the right assets, the data sets to analyze, and the notebooks to analyze it, and the guidance to interpret the results. So therefore, asking something as simple as how do I compute the surface ocean temperature in Amsterdam from 2022 to 2023 becomes a maze of scattered portals to find data sets, inconsistent metadata, and finding appropriate code or notebooks to analyze it, and a lot of guesswork, especially for early researchers. So our current solution today options offer a trade-off between a curated catalog of services that deliver high quality but demand human expert for indexing and processing. On the other hand, keyword searches scales cheaply but often returns irrelevant results, which furthermore takes a long time to manually process by the end researcher. Therefore, researcher has to move up and down a lot between search services and catalog of services. So introducing NVHub Next, a dialogue-first LLM-powered system that blends the strength of curated catalogs with the richness of classical search. And the outcome? Faster responses to queries, generate reproducible workflows and across infrastructures, and shared platform where researchers can find, analyze, and collaborate without switching tools too much or lowering the bar on quality. And with that, let me show you how NVHub Next turns a complex query into a transparent end-to-end workflow. Now we're going to demonstrate how to answer the query. How do I compute the surface ocean temperature in Amsterdam for 2022 to 2023, which is also an essential climate variable. Initially, we go to the knowledge base here, you can see, and search with the query surface ocean temperature. We see a summary of results, which are categorized into 4 classes, including a detailed option for datasets. However, early career researchers may not be familiar with what an ECV is. Therefore, we have included a chat assistant that provides helpful answers, including what an ECV is. From the chat assistant, we can also go to the fuller version of the dialogue-based system. So this is our dialogue-based system. We're going to show straightforward steps to answer the question here. First, we ask the system the research question itself. This way, it establishes a context of communication. From the answer, we can see that the system has responded, starting with the data collection steps, including a set of relatable URLs. Let's wait for a second. So now then we ask the relevant data sets required to answer the original research question, and we get an appropriate response, including the catalog of services, which we can go now. So we're not going to spend too much time on it, but our system can redirect to the catalog of services as well. And finally, since the researchers may not be expert in coding, we can also ask the system to complete a sample code with appropriate formula library and dataset, and which the system does it for us beautifully, and also give us the libraries to install. So this way, early career researchers, as well as experienced researchers, can gain significant advantage in their queries answering a research question in a seamless flow from question to a definitive reproducible answer. Finally, we ask an interesting question. How can NV become an EOSC node? We see that the system has provided answer including legal requirements, services, policy, quality, and also the onboarding process with an official reference. So this demo, part of the NVHub Next project, helps position NV community to join the EOSC as a candidate node. The services are standardized and domain agnostic, so it can be generalized beyond the environmental science and offered as an open source infrastructure for other communities as well. Thank you, everyone, and have a wonderful day.
Thank you. All right, we're approaching the end of this lightning talks and demo with the last presentation by Thanasis Vergoulis, who is going to tell us about how to make research assessment resources easier to discover. Thanasis.
Can you hear me now? Okay. Thank you. I'm Thanasis Vergoulis, and apart from the role that I have at Athena Research Center, I am the Chief Technical Manager of the Graspos project. It is a pleasure for me to present you, to give you a glimpse of the main output of our project, which is an infrastructure that collects resources valuable for responsible research assessment. Our motivation was related to the fact that the open science activities are not properly acknowledged, and although there are multiple open resources that can help responsible research assessment, they are not always easy to discover. Because of that, apart from that, there is also a lack of standardization in sharing relevant metadata for those resources, making their discoverability even more difficult. The mission of the project is to create an EOSC integrated open infrastructure that enhances discoverability and interoperability of resources that can support what we call open science-aware responsible research assessment. You can find more details on the QR code. When we are talking about resources, we are talking about datasets, services, tools, templates, and guidelines. All these resources are discoverable more easily through our infrastructure. The main architecture of the infrastructure is displayed on the slide. So we have a series of core catalogs collecting the different types of resources and the core metadata about them. We have some standards that we have created about their interoperability, creating a data interoperability and access layer. And we also integrate everything into one single meta catalog that collects and enriches the information about all the resources, supporting various scenarios about their discoverability. And we offer this through a UI to the end users. Everything is also synchronized with the EOSC ecosystem because all the resources are available to the metadata of the resources are synchronized to the EOSC Resource Hub. So here you can see the main interface. The user can use some keywords to search for resources. The results appear with some very basic metadata. You can rank the results based on different criteria. And there are, at the left side, a lot of facet filters that can be used to support the exploration, the better exploration, and identify the resources based on different scenarios. For example, you can use the value that you would like to use for a particular research assessment event, what is the subject of assessment, and things like that. And there is a very brief summary that you can see, but then you can click and display more details in a detailed page. Now, after the end of 2025, a clear resource inclusion policy will be released so that everyone will be able to provide their own resources in this meta catalog. Until now, we have just collected a lot of resources produced in the context of the Graspos project. And with that said, I would like to thank you for your attention. If you are interested, there are some links here. You can scan the QR codes. And I would also like to get the opportunity to mention that next week in Pisa, we are presenting our final dissemination event. We are going to have more than 140 participants. We will be happy to provide more details about everything. Thank you again.